Question 5. Fairly tricky vectors question, but it comes down to making sure you know the difference between a position vector, a lowercase bold vector, and a point, and coordinates, and just making sure you know the difference between all of those and how they work in algebra. So, really good diagram necessary for this question, and I saw in the mock a lot of bad diagrams. People were really struggling to work out what was going on with points A, B and C. But point C lies on AB, so you should just really have one line, but you might want to also mark on the origin to help you understand what the position vectors mean. So that would be a good place to start. So I've drawn some origin somewhere. It doesn't matter where you draw it, just an arbitrarily chosen origin. Points capital A and capital B connected with the line, and position vectors of those points. O to A is little a underlined, and O to B is little b underlined. Now, point C lies on AB, so draw it in a random place, and we're told that the ratio of AC to CB, so AC to CB, is p to 1. So you can see I've drawn a little p and a little 1 to indicate those relative distances on the diagram. And the question, part A, asks for the position vector of C, which I've drawn on in blue. Well, how do you get from O to C? We can't go directly there because we don't know what this vector is. So we need a different route. We can either go via A or we can go via B. I chose to go via A. So we need to do O to A plus A to C. Well, we know O to A is just little a. Now, A to C is a proportion of A to B. And that proportion is, if you think about it, it's p plus 1ths of the length of AB. If p was 4, then it would be, it'd be 4/5, wouldn't it? Because it's 4 and 4 to 1, so 4 out of 5. But we don't know what p is, so it's p over p plus 1. And of course, A to B, how do we get from A to B? Well, we have to go back via O, so it's minus A plus B. Or in other words, B minus A. So if we replace A to B with B minus A in the algebra, you've done the hard bit now. You just need to make that look like the thing in the question. So notice that in the question, they've got one term with 1 over p plus 1 factored out of the whole thing. Whereas at the moment, we've currently got 2 terms. So somehow we need to take 1 over p plus 1 out as a factor of both of these 2 terms. So I've done that like this. So I've left we've still got this p times b minus a, that's here. But I've taken the 1 over p plus 1 out at the front. But to create just this a here, I've had to do p plus 1 times a. So you can imagine if you did this term here times the factor, the p plus 1s would cancel, just giving you just this a. And then if you expand the big bracket, expand what's inside the big bracket, and then you spot that there's a PA and a minus PA that cancel, and that gives you the result that we want. In part B, remember that quite often you get to show that question in part A, and then something else in part B, and that uses the previous result. Not always, but in this case it does. It often does. So you're given A and B, so an obvious thing to do is to substitute those in to the result from here. So even if you struggle with part A, you can still do part B. You still do part of it anyway by substituting those in. So we've got 1 over p plus 1, A plus p lots of B. So I've just multiplied each component of B by p over here. I've then decided to group together the i's, group together the j's, and group together the k's like that. And only now do we really need to think carefully about what the question's asking. Point C lies on the y-axis. If it's on the y-axis, a lot of people in the mock thought that means that the y-coordinate must be 0. It's quite the opposite, actually. If you just draw a little sketch of some 3D coordinate axes, draw a point on the y-axis and try and write down what its coordinates might be. Well, we've got 0 in the x direction, something, I've written 3, in the y direction, and nothing in the z direction. So the only way something can be on the y-axis is, in fact, if the x and the z components are 0. So, in other words, 2 minus 6p needs to be 0, which gives you p equals 3, and also minus 4 plus 12p needs to be 0, which, thankfully, gives you the same result.